thank you so much for coming here. I know I'm between you, beer and finger food, but everyone knows that ACI and PBR is like the best, right? Anyway, welcome to Lessons Learned from Migrating ACI Customers from the traditional Firewall Insertion to PBR, Policy-Based Redirect. My name is Kampan. I'm a solutions engineer. I'm out of Sweden. If everyone thinks I have a weird accent, I do. And the BBC hasn't helped it much lately. But anyway, aside from spending a lot of time doing data center switching and ACI in particular, I like hiking, running, which is a good thing because I love food, I love cooking, and I love good drinks, which I'm looking forward to after this. But right now, we're going to focus for the next 59 minutes on ACI and PBR. Alrighty. The Cisco WebEx app. You've heard it a bunch of times already. Please join the space if you have any questions. We will have some time for questions at the end of this session, hopefully. But still, join. You can download the presentation. As I mentioned a couple of minutes ago, I updated the presentation, so there is a 1.1 version up there right now. So if you have the old one, delete it, download the new one, okay? Anyway, the WebEx space will be moderated until June 7th. I will keep it. So if you have any questions, that's a good way to get a hold of me anyway. The agenda for today, we're going to go through a couple of recommended sessions, quick level set, the customer examples that you're here for. We're going to go through 5 customers, conclusions, and Q&A. Recommended sessions. The first one, unfortunately, that one was early this morning. So Steve Sharma's excellent session about ESG was one of the first ones out the gate. So ACI, the foundation of an internal private cloud. Excellent session, talks about ESG's endpoint security groups. If you haven't seen it, I highly recommend you to watch it later. So really, it's a really brilliant session. Tomorrow you have the opportunity to listen to Minako Higuchi, ACI layer 4 to 7, policy-based redirect, deep dive, and tips. And when it says deep dive, it really means deep dive. So that's a great session. We'll teach you the ins and outs of PBR. And after that one, you have the opportunity to go to Michael Garcia's great ACI troubleshooting, a deep dive into PBR. One thing implementing it, another thing troubleshooting it. So go to those 2 sessions if you can, if you haven't signed up already. Wednesday, my colleague, Fabian, talks about ACI and PBR from another standpoint. He comes from the security side of the house. So he's talking about secure, firewall, and ACI and how they can work together, things to do, things not to do, and so on and so forth. Excellent session, especially for those who loves the charming French accent. And finally, Steve has a lab as well. Go to that lab if you want to play around with ESGs and learn more about ESGs. Excellent stuff. All right. Quick level set. We're going to spend quite a lot of time here, a bunch of minutes, just to make sure that everyone's on the same page. Okay? Contracts. Everyone knows contracts. We need contracts to be able to communicate per default between different EPGs or different ESGs, right? We have the weirdly named consumer. We have the weirdly named provider. A weird way to say we have a source and we have a destination. The contract first and foremost defines which traffic is allowed between these 2 guys. But it also controls quality of service, routing, and service insertion. And service insertion is what we're going to talk about today, right? Sharing contracts. You all know this, but it's worth repeating. If I have 2 EPGs, the blue one at the top and the green one at the top, they need to be able to communicate using TCP 443, for example. Excellent. I create a contract. I apply it. I have one consumer, the blue one, and I have a provider, the green one. A couple of days later, I need to have the blue one at the bottom communicate with the green one at the bottom using TCP 443. Let's reuse the contract and save 5 seconds of my life, which can be a great idea or not so great idea, because all the consumers of the same contract will be able to communicate with the providers of the same contract. Worth pointing out. That's why we have clone nowadays. So you can just right-click on your contract, clone it, and off you go. VZN. VZN is really important. It saves hardware resources, and it's very convenient. It applies to all EPGs or ESGs associated with the VRF. Everyone who's associated with a VRF today, everyone who's associated with a VRF tomorrow, or 5 years down the line, which is really, really good. So we can provide contracts, we can consume contracts, we can provide and consume, of course, one contract or more contracts. So that's not really a problem. In this case, this example, I provide C1 and I consume C1, which means that C1 is consumed and provided by everyone, which includes the external EPG or external EPGs associated with any layer 3 outs in the same VRF. That's really, really important as well. Why does it matter that we save hardware resources? For one, we're going to have one single entry in the TCAM, the tertiary content addressable memory, which saves up space. How many have blown through more than 50% of the TCAM for policy? Oh, not using contracts that much, are we? Okay, there we have someone. Remember who bought ACI in the first version, basically the first generation hardware? Yeah. Do you remember how much in policy TCAM there were in the modules? 4K, yeah. And then everyone realized, okay, no, this is a problem. So they released a new module, uplink module, 8K, which everyone blew through like immediately anyway when they started using contracts. Nowadays we have more. Usually it's 64K, and you can usually change the profile to get up to 256Ks. But still, instead of one entry, instead of like 50 entries, if we have 50 EPGs using the contract, we will have one single entry. And more importantly, for a lot of customers at least, that means that we will update things much, much quicker. So instead of having to churn and update 50 copies of the same contract in the hardware, we just update one, which can save you a lot of time and which will minimize the impact of doing a change, which usually people like. VCN, we find it under the EPG collection for VRF. Weird name, but anyway. So we can provide contracts, which we do in this case, and we can consume contracts, which we do in this case, yeah? So what can we use VCN for? It applies to everyone in the VRF, right? So in the first example over here to the left, let's point at it. In this case, we have VCN consumer, so all the EPGs in this VRF are consumers, and we have a single provider, EPG A. In this case, it provides syslog, for example. So everyone in the VRF is allowed to send syslog to EPG A. That's the only thing, right? In the middle, we have the reverse. We have a single EPG A that is the consumer. EPG here is VCN are the providers, which means in this case, SNMP, for example. Old protocol, I think SNMP should die a horrible death in fire or something like that. It's overstayed its welcome, I think. But anyway, people still use it. So in this case, EPG-A would be able to communicate using SNMP with all the EPGs in this VRF, for example. And the final example, ICMP. The contract is both provided and consumed by everyone, which means that anyone in the VRF can ping everyone in this case. So those are typical uses for VCN. And do remember, we do not allow shared providers. Shared is a key word in ACI, you know, which implies that we're doing things across VRFs. So we can't have a VCN provider in one VRF providing things to another VRF. That's not allowed. We can have consumers using VCN, consuming something in another VRF though. And that applies when we're doing PBR as well, of course. There's an excellent paper how to use VCN to optimize your usage and everything. Contract priority, this one is just for reference. Don't try to read it. Contract priority, really, really important. We're gonna use that a lot today in our examples, yeah? Consumer provider, at the bottom of the totem pole, there are some lower, one lower at least, but still, low priority. VCN to VCN, for example, 17 or 21 in priority. It's always hard for me to discuss priority. High priority is usually a lower number, which, yeah, it makes it complicated. VCN to a specific EPG, 14 and 16. VCN to, EPG to VCN 1315. We have a specific EPG, and we consume something that VCN provides. And finally, fully qualified, 709. One specific EPG consumes, and one specific EPG provides. Very basic, but still is real important. Contract priority. More specific wins, as always. We saw that already in the previous slide. So low priority, unspecified protocol. A little bit higher IP, higher though TCP, and even higher TCP/22, in case it is TCP/22, of course. Otherwise, we will always hit TCP, as long as it's TCP traffic. This differs from the normal things that a firewall does. Firewalls does lazy evaluation, which means that as soon as they hit something that matches traffic, it might be the third rule, it might be permit any, then it will exit the evaluation and pick that rule. We're doing things in hardware for good and for bad, which means that we can, without any penalty, actually look at the longest prefix match equivalent. So we pick the most specific one. And finally, action. Here we have deny and log, which beats deny, which beats redirect, which beats permit. But this only applies after all the other things. So this is sort of the tiebreaker, right? So this won't matter if the protocol doesn't match, for example. Let's have a look at an example. This is an example topology. It's bug ugly, I know. But we have row APG, we have sigma, and we have tau. In this verb, we have a VCNE. We provide one contract, consumed, one contract, and two contract. Bad name, I realized that earlier, but I didn't have time to change it. So we can see that we provide and consume contract one. Contract two is consumed by everyone and provided by row. And then we have two more specific contracts, which is TCP, contract three, which is consumed by sigma and provided by tau, and contract TCP/22, consumed by sigma, provided by tau. Just to have a look and see at the priorities. So the topology, looking at the application profile, looks like this. We can see that we have contract 4 here, for example. Provided by tau, consumed by sigma. Same thing with contract 3. Provided by tau, consumed by sigma. And we can see contract 2. Provided by row, consumed by VCNE. But where's contract 1? It's not specifically applied to any EPG in this application profile. Hence, we don't see it, because it's any. So, as we can see, we provide one contract, consume one contract, and two contract, or contract 1 and 2. Looking at the zoning rules in one of the leaves, the VCN consumer and provider is any, and we can see that as well on the source EPG and destination EPG, source tag, 0, everyone, 15, magical, 000/0, for example. And it's any, we have priority 17 as expected, as we saw earlier on the slide. VCN consumer and rows the provider. Will we have lower priority? Higher priority, which means a lower number or not, compared to VCN to VCN? Anyone? We have higher priority, so we have a lower number. We have 13 and 14. 0 to 16388, 16388 to 0. Which means, of course, that this one will have precedence compared to the VCN to VCN. Contract number 3. It's consumed here. It's TCP, and we consume it on sigma, and we provide it on tau. Will we have higher priority, so lower number compared to the other two? Yeah, of course. In this case, we're fully qualified because we have a specific EPG to a specific EPG, which gives us priority 7. Now, for number 4, which was TCP port 22, will this one have higher priority compared to contract number 3? Same, thank you. It's the same, because we're still fully qualified, EPG, TPG. The tiebreaker will take place within that priority, right? Very good. So, what are we trying to move away from? Why do I wish I had the time machine and could go back in time and visit myself and give myself an ACI fabric back in the days when I was working with production and doing operational stuff? This is one of the reasons why. Typical traditional service insertion. Firewall as a default gateway. How many of you have implemented that? Yeah. How many of you are still using that despite using ACI? Oh, I hope I can help change your mind. Anyway, one of the pros, it's very, very simple. Everyone can understand it. And all the traffic passes through the firewall. That's a good thing, right? Until it isn't. The bad thing is all traffic passes through the firewall by default, unless you start doing a funky host routes or something like that. And scalability. It's very easy. Nowadays, a lot of customers are using 25 gigs to the servers. How many of you are going to 50? Okay, too early. But anyway, 25, yeah. Yeah, that's an odd one, but yeah. 40 was all the rage for a while. But if we have a bunch of servers connected with 25 gigs or 10 gigs, it doesn't take that many servers before we can overrun our firewall, regardless of which firewall we have, basically. So that's the problem with scalability when it comes to pushing all the traffic through the firewall. Another one that I really, really, really dislike, mostly because I'm too stupid to understand that I have a transparent device in between and I forget things like that. Transparent firewall. And do remember, it can be a load balancer, it can be something else. I tend to talk about firewalls, but it could be another type of service device. On the pro side, simple. All traffic passes through the firewall, and it's easy to implement without changing anything. You can still have your default gateway up in your router, your switch, or wherever. On the downside, all traffic passes through the firewall, scalability. You can't use MST in traditional networks. In ACI, we don't care. But in the old networks, we had to care about that because we couldn't rewrite the MST BPDUs, which led to scalability problems in some cases, yeah. And usually it relies on the device high availability to avoid loops. A bad day usually happens when you get the active-active. Split brain. Gets worse because it helps you loop your network as well. So really, really bad day got even worse. So it's a Monday. Finally, this is a really, really common design. Firewall sandwich between VRFs. The good thing is that only traffic between VRFs passes through the firewall, which means that we can see each VRF like a security zone. Within the zone, we can communicate freely. Between zones, we have to go through the firewall. The bad side is that unless we start doing policy-based routing, not redirect, all the traffic between the VRFs passes through the firewall. This can lead to sprawl of VRFs and linking networks as well, right? And scalability issues once again. So this is what we're trying to get away from. This is the old world. Welcome to the new world. Service insertion using policy-based redirect. The traditional one that we had since ACI 2.0 is that we have a service device in a shadow BD. Why is it called the shadow BD? It's called the shadow BD because it sounds cool and everyone sort of remembers that. Or it's because we have a BD that doesn't have an EPG, that we create at least. The system will create an EPG, it keeps it hidden from us. So the BD is actually the link network, sort of. That's sort of the thing. This makes it very easy to do firewall insertion. We don't have to be in the path anymore. We can just tell them, the fabric, redirect this traffic or this type of traffic, this is specific traffic, for example, between A and B to the firewall or to a firewall and a load balancer or a firewall and IPS or what have you. From ACI 5.2.6, we got service device behind the layer 3 out, which is really, really convenient at times. First it was like, really? What is this good for? Then I realized this was really, really good. In this case, we don't have the device in our VRF anymore, necessarily. And it doesn't live in shadow BD. It lives on the other side of a layer 3 out, which gives us more flexibility. This is a good thing. This is not supported today using multi-site. How many of you guys are using multi-site? Yeah. We'll talk about that, because I had a customer that is going to use multi-site that needed to do something like that. Anyway, one of the good things about PBR is symmetric PBR, which means that we can scale horizontally. We have a firewall, for example. We hit the performance, we push enough traffic so the firewall croaks. We need to be able to push more traffic. For example, LAN backup chews up a lot of bandwidth. So what do? We call our rep, of course, and he comes with a truck, beep, and we forklift everything. We rip out our old firewall, put in a bigger box. That's the old world. That's what we used to have to do. Or we could cluster. How many likes firewall clustering? Yeah, it's been around forever. Most people dislike it a lot for various reasons. It works. It's fine. It's been around for ages. What we can do instead, ACI gives you the option. It doesn't force you to do it, but what you can do is use horizontal scaling instead, which means that basically the fabric will load balance traffic between several firewalls for you, which is really, really neat. I have a big bank that is looking to do this, for example. Banks don't get rich from spending money. They get rich for not spending money, basically. And they're looking to have a better model, pay as you grow, basically. So when they need more capacity, they're looking to add another firewall in parallel with other ones. And nowadays, you can give them weights. So for example, if you have a new firewall, that one is 50% more powerful, which means that we can send 66% of traffic to the new one, 33% of the traffic to the old one, for example. We can do stuff like that, which is really, really powerful. Multi-node PBR. In multipod, you can have up to 5 devices. I can't even figure out what the 5th device would be. So I just put a question mark. Maybe a DDoS thing or something like that. So you can have a load balancer, you can have a firewall, you can have an IPS, you can have a mystery device, and you can have a load balancer to re-encrypt traffic, for example. The customer that uses most nodes that I know of, at least that I work with, uses 3 devices. Most customers just use 1. If you're using multi-site, remember you're limited to 2 devices, like a load balancer and a firewall. Keep that in mind. Send traffic selectively to service devices. We talked about this implicitly when we talked about the contracts. If we have E and R, for example, we can send IPs, which means basically all the traffic up to the topmost firewall. But maybe we want to send TCP 443 to a load balancer to terminate the TLS and then send it to a firewall, for example. Then we can have a more specific contract, which says TCP 443. TCP 443, as we know, will hit that contract instead, which sends it to another service graph, for example. And then we can have an exception like TCP 12345, which could be LAN backup traffic or other high volume traffic or something that is extremely latency sensitive, for example. That means that we will do fabric enforcement. You have those options. That's why I wanted to spend some time on the contract priorities and those things. Remember, the device must be in the consumer or provider VRF. So in this case, everything is in the same VRF, happy days. In this case, we have the device in the consumer VRF, or we have it in the provider VRF. All those are legit. What we can't have is a consumer VRF, a provider VRF, and a third VRF, like a neutral VRF, where we have our services. That's why I like to have as few VRFs as possible in ACI. I do understand why we migrate into ACI. We're going to have something that replicates the old environment one-to-one. But after the migration phase is over, I like to try to migrate my customers to having one single VRF, if possible, or as few as possible at least. We can do the same subnet service insertion. That was really, really tricky to do previously. With PBR, it's easy. We just do intra-EPG isolation, slap on a contract with a service graph and do PBR, which means that we can apply a firewall, for example, between nodes in the same subnet without a problem. Clustering makes several devices look like one logically. If you're using FTD, for example, or ASAs, you can, depending on the model of your box, have 8 or 16 nodes in your cluster, which means you will have a fairly decent bandwidth or throughput. Can span multiple data centers, handles asymmetric traffic, concurrent and new connections, and throughput, of course, scales. Finally, FTD dynamic objects, released in 7.0. Really, really good thing. How many of you are aware of the FMC endpoint updater app? It's something you can, great. You can install it on your APIC. It will move eventually to the CSDAC, which is included in the FMC in the latest version. But that's the plan, at least. Anyway, it will take your EPG or ESG members and sync it to the FMC every minute or per default, which is really, really good. And nowadays, using dynamic objects, you don't have to do a push. You don't have to push policy to the firewall for the firewall to be updated and know about these updates. Yeah? Which makes it less disruptive and more dynamic. So like every minute or every 2 minutes, basically, your firewall will be aware of new IP addresses in an EPG or ESG, or whenever something has timed out. We don't see it anymore, it removes it automatically, which seldomly happens in the real world, at least where I've seen it. So this is a really, really neat thing. Okay, moving over, customers. Customer A. Customer A had 2 goals. They wanted simplification of the environment, mostly routing, improved security and flexibility. The requirements were they were using NAT, and that is together with this VPN firewall. And they wanted to have stateful failover in the 3 data centers. So they wanted to be able to lose 2 of the 3 data centers and still retain state for whatever traffic was remaining and whizzing around in the 3rd, the surviving data center. So how did we do this? We simplified the environment. We migrated from 11 VRFs to a single VRF. We implemented the firewall as active-active cluster. We created 2 VRFs in the firewall, 1 for internal traffic, 1 for external traffic. And we migrated contracts that was within the VRFs up to the firewall. So the firewall does all the enforcement now. We don't have any contracts right now with any exceptions or anything like that. Of course, you could have created exceptions for traffic that used to be in the same VRF, but they wanted to push everything up to the firewall instead. We use one-armed firewalls because routing, it makes life easy, because then we just have to have a static route. 0000/0 pointing out. Everything lives outside me on that interface, basically. And they wanted the flexibility, so now they're ready to go take the next step, to start implementing ESGs, implementing the FMC endpoint updater app, and often go to the races and start doing macro segmentation for real. So this was the initial logical topology. They had 11 VRFs, 1 to 11, and everything was routed out from each VRF up to the firewall, which connected all the VRFs. Of course, they had another layer 3 out as well to the core, but it's omitted just for clarity's sake. The final logical topology, a couple of hours later into our change window, when we moved everything from whatever VRF they were living in to a single VRF, looked like this. We have our layer 3 out to the core and the rest of the world. We have our internal firewall. We have our external firewall or our internet firewall. And we have a bunch of EPGs within this VRF. So the physical topology looks like this. 3 pods, 1 active firewall per pod. We have an IPM connecting us. The east-west traffic. We use C1, contract C1, which defines IP and PBR to the internal firewall, the red firewall, up in the left corner. We use VCNE to make it easy. which means that everyone consumes and provides this contract. So anyone in the VRF is allowed to communicate with anyone, but they will hit the firewall. So we have our VCN, priority 17, of course, because it's VCN to VCN. The flow looks like this. A and R are in the same VRF, because we only have one VRF now. So we have a direct route. So the traffic will hit C1, because that's IP. As long as it's IP traffic, it will hit contract C1, which PBRs the traffic to the internal firewall. The internal firewall does the policy decision, and if it permits the traffic, it will send it on to the provider. If we have return traffic, it will be sent out from the provider. It will hit contract 1 again and be sent to the firewall. Firewall does its policy decision once again, and if it permits the traffic, it will go down to the consumer. Questions so far? Clear? North-south traffic. We have another contract, C2. IP contract once again, and PBR to the internet firewall instead, the blue firewall, up in the right corner. Everyone is a consumer of that. It's a VCN consume contract. But on the external EPG for the layer 3 out, we provide this as well, which will give us a better priority, right? So what do we do? We consume the contract as a VCN, and we provide it on the external EPG. So we have 13 and 14 in this case as the priority. And that's why we override 17. The VCN to VCN, the C1 contract. C2 will override that as long as we are routed to the external EPG. So this is why we spend time looking at all the priorities. We have a route in the VRF, which is the 000/0, pointing out from our layer 3 out. The traffic will hit contract 2 with PBR to the internet firewall. The internet firewall does its policy decision, and if it permits the traffic, it will send it out through the layer 3 out. Any return traffic will match contract 2 again on the return, is sent to the internet firewall, and the internet firewall does its policy decision and returns the traffic down to the consumer, if it's permitted. So that's the north and south and the east and west flow. Are you with me so far? Easy. The NAT, how do we fix the NAT? We don't have any route. So that's why I introduced a dummy layer 3 out in this case. The dummy layer 3 out is a dummy. It's just a static port, basically. Or rather, we're using the same as the layer 3 out. We just use another end-cap. So I don't even have anything on the other side. I just have a fake next hop, just to introduce a route. So in this case, and the internet firewall is the one doing the NAT. This is where it becomes a little bit more interesting. First time I saw this, I didn't understand it, to be honest. It was like, what's happening? Then I realized that this was a really, really smart thing. So what we do here is basically we create our dummy layer 3 out, and on my configured nodes, I add a static route to my NAT range. In this example, I use 192.168.10/27. Same thing on the other node, of course, because I want redundancy, which means that I will have the route in my routing table. So the fabric knows where to route it. Otherwise, it would just try to route it back out 000/0, right? In this case, traffic to the NAT range will be sent towards my dummy layer 3 out with my static route, but we have contract 2 in place, which means that we will match that traffic on contract 2, send it to the internet firewall, which will do the NAT translation and send it to the real server instead, which in their case was the VPN firewall. So we have the source 10.10.10.10, or 10.10.10.10, sending traffic to 192.168.1.11. We have a route, so we know where to send it. We will hit the contract 2, we will be sent to the internet firewall. The internet firewall has the NAT statement. It has the static NAT. So it does the address translation. So source is still intact, of course. Destination changes. So we'll send it to the real destination instead. If the real destination returns in the traffic, we will hit contract 2 and be sent to the internet firewall, which means that the internet firewall will do address translation again and send us out on the 000 layer 3 out. That's the way we can take care of NAT, for example. Another way would have been to introduce BD in that case. We could have done that using BD as well. Conclusion for customer A. PBR simplifies the network topology. It removed 10 linked networks, 10 interfaces on the firewall, and changed the routing on the firewall. Instead of keeping track of which address was in which verve, we just could do a static route, 000/0. We use more specific contracts to make sure that we sent the traffic to the right firewall. And we took care of the NAT using a static route, just a dummy layer 3 out to know where to route it, to have the traffic being sent to the firewall, right? We just need the route, and we need to associate EPG with the right contract. Customer B. Customer B has the goal to simplify insertion of services. They want more flexibility, and they want to improve security. Everyone does. The requirement was they wanted to apply firewalling within the tenant and between their tenants. A strict requirement from them were that the firewall should be a single routed instance, which limited our design choices. They didn't want to implement any verves because the firewall admin told me that using that vendor, it was complicated to implement verves for some reason. And they didn't want to use any virtual instances or more hardware either. So we had one big honking box that should take care of everything within tenants and between tenants. And they wanted to implement multi-site, which meant that we couldn't use what would have been a natural choice, the PBR device behind the layer 3 out, right? So how do we do it? Well, we use a single verve per tenant to make life easy. The firewall has an interface in a shadow BD per tenant, and we use the dummy layer 3 out again. The dummy layer 3 out in this case doesn't point at the NAT range, it points at 000/0. The logical topology looks like this. In this case, they had 4 tenants. Each tenant had a single verve, a couple of EPGs, and a layer 3 out. The layer 3 out is just a dummy, so we get the 000/0 route, remember? And we have the shadow BD where the firewall has one interface per tenant. So the east-west traffic, we use VCN again. We have a contract 1, IP, matching IP, and we do PBR to the firewall. So everyone's consumer, everyone's provider of contract 1. Which means that all traffic will hit contract 1. We consume the same contract using VCN, and once again, we wind up with priority 17. Packet walk is basically the same. A wants to communicate with R. Both are consumers and providers, so we have a route. We will hit the firewall, thanks to contract 1. Firewall does applies its policy, and if we are permitted, we are sent on to R. Return traffic, same thing. Hits contract 1 with PBR and sent to the firewall. The firewall applies the policy, and if the traffic is allowed, it's being sent to the consumer back. All good in the hood. North-south traffic, it's the same thing. We still hit contract 1, because we have the fake dummy layer 3 out. In this case, I wouldn't be asked to do it redundant, but do you understand? We have a 000/0 pointing somewhere. It's just a dummy layer 3 out, which means that we have the route, so we know where to route things. In this case, we have the blue guy, A, is in one tenant. E, the gray guy, is another tenant. as you can see here, down here. We have our firewall connecting the tenants, and we each have one dummy layer 3 out per tenant. So traffic to an IP address not in the VRF. Within the VRF, we have seen already, not in the VRF, is routed towards the dummy layer 3 out, of course, because that's our 000/0. Here, we're going to match contract 1, and we will be sent to the firewall. This firewall has the routes to the different tenants, to the different scopes, right? Which means that the firewall, instead of sending it back so it can go out, which it can't through the dummy layer 3 out, will route traffic. It's like, yeah, this one lives in tenant B, and I'm going to send it there. So it sends it to the right. It goes down. It's the provider. If the provider returns in the traffic, it will be sent towards its own dummy layer 3 out with the 000/0, because A doesn't live in his routing table. Once again, it will hit the firewall, and the firewall does the routing and returns the traffic. In this case, because we had this limitation that we couldn't use the PBR device behind layer 3 out and the design constraints the customer gave us, we had to use the dummy layer 3 out in this case. 000/0, just to introduce it somewhere. This design fulfilled the customer's requirements while keeping the overall network design simple. The downside with this is that we can't do dynamic routing, because we can't do dynamic routing to a shadow BD. We need to do that to the 3 out. But this customer is deploying this as greenfield, so they could do good summarization of the subnets per tenant, which made it easy anyway. This makes it easy to create exceptions, because they're looking at doing exception for LAN backup, for example, so it doesn't hit the firewall. And it makes, for them, it's really, really important. It's super easy to audit. Beginning, straight out of the gate, they have a single contract per tenant, which means that they can either use the WebSockets and set up a subscription, asking regularly, or rather having a push whenever someone creates a contract. Or they can go and query the fabric every 5 minutes, every 5 days, every 5 weeks, 5 months, or 5 years, or whatever. Do we have any new contracts? Do we have any exceptions in my contract, in my fabric? Which is very important to them. Okay, moving on. Customer C. Customer C, same goals: simplified insertion of services, improve security. Everyone wants to do that, right? Their requirement was that traffic within and from and to the red zone should hit a load balancer to terminate any TLS, a firewall, and a layer 2 IPS. I like to joke with them that you should switch to firewall vendors. Why use a separate IPS? But it tells me they like the crummy firewall that has a shitty IPS, sorry, language, a beep IPS, and they like their external IPS for various reasons, okay? Traffic in the blue environment, on the other hand, should just go through the firewall. So how did we do this? They created 2 service graphs, one with 3 devices, one with a single device. So the final logical topology looked sort of like this. We don't care about the layer 3 out in this case. We have the red environment to the right. We have the blue environment to the left. We have a load balancer. We have a firewall. We have an IPS. So what to do first? Red. Within red and to and from red. They have a contract, contract 1, matches IP, and PBRs everything to this chain, the load balancer, the firewall, and the IPS. It's a chain of 3 devices. They still have 2 more to go. I like to joke with them that probably soon they're going to realize, okay, the traffic going out through this chain is unencrypted. Maybe we should encrypt it, so we'll want to add the load balancer again to encrypt the traffic, but we'll see. Anyway, we provide and consume the contract within the red zone, all those CPGs, and we consume the contract in the blue zone, which means that they are allowed to communicate with the red, and red is allowed to communicate, but it will be sent to the chain with 3 devices. Traffic within blue is taking care of a second contract, C2, which matches IP and PBRs to the firewall, only the firewall in that case. In that case, we are a consumer and provider. All the APGs in the blue zone are a consumer and provider of the C2 contract. And thus they hit that and will only go to the firewall instead. Conclusion in this case, service insertion is easy using PBR, gives a lot of flexibility, and it was great for them because they started off with a service chain using 2 nodes. Then the security guys came knocking on the door, told them that, hey guys, we really want to terminate the TLS, and we don't want to do it in the firewall. Can you please fix that for us? We have a nice load balancer from a 2-letter company, and we would like you to leverage that one. I didn't name any names, right? We would like to leverage that one to terminate the TLS, send the unencrypted traffic through the firewall and our IPS, right? So it was very simple for them to just add a load balancer and change the service chain, which is another plus of using PBR. Customer D. You've seen the goals before. Everyone wants that, right? In this case, the requirement was that all traffic between endpoints in this environment should go through the firewall, regardless of if they are in the same subnet, neighbors, or what the heck ever. All the traffic should go through the firewall, except for the LAN backup traffic. How? In this case, they implemented ESGs, endpoint security groups. And we did intra-ESG isolation with contract, with PBR. And we use a more specific contract, like TCP 12345, that matches the LAN backup traffic, so it can bypass, so that one is enforced in the fabric instead. Because we have had this discussion for like 6 years. It took them 6 years from the initial discussion about this before they implemented it and went through the second ACI fabric. But anyway, finally they implemented it and they're really, really happy. Because basically they told me that, okay, the LAN backup traffic is overrunning our firewall. Our firewall guys don't want to pay $1 bazillion to get a bigger firewall. My joke answer to them was basically, as long as your SLA is like backup every 24 hours, you keep the SLA as long as the backup completes in 23 hours, 59 minutes, 59 seconds, and 99 hundredths. But no one will be happy when you do a restore and it takes that long, especially if you have to do multiple restores. So this is the final logic and topology they wound up with. They have a layer 3 out. We don't care about that one really. We have firewall. We have a handful, and I really mean a handful of ESGs in this case. It doesn't really matter. It could have been EPGs. So what's happening here in this case? They have one contract, C1, which is consumed and provided as an intra-ESG contract. This one is an IP contract, as always, almost, and it has a PBR to the firewall. The ESGs themselves also provide and consume the same contract, which means that anyone and everyone is allowed to communicate with everyone per default, but it will be sent to the firewall. Do make note, I should have written that these guys are the backup service in the backup ESG. They do not consume and provide the contract one, because they don't have to in this case. They use contract 2, the blue contract. Contract 2 is consumed by all the other ESGs. We don't care about the intra-ESG, because this is out from the ESG into this one. And the backup ESG provides the contract, which means that this one is enforced by the fabric. So all that nice LAN backup traffic that I like to say, we at Cisco love LAN backup, because finally someone pushes some traffic through the fabric. I mean, most customers don't use the fancy 100 gig links, multiple 100 gig links, or 400 gig links. Some people do, but most, no, not so much, maybe. The conclusion for customer D. Inter-EPG ESG contracts makes it easy to send traffic between endpoints in the same subnet to the firewall. Really, really powerful for those people who really needs to do micro-segmentation. More specific contracts, overrides, and provides the exceptions. I have one customer that are looking to, maybe they will be in the deck next year if I'm allowed to come back, but anyway, they are looking to start implementing PBR now. And they would like to use more specific contracts in their case to have real-time video traffic to the servers in the data center, bypass the firewall. So they always can tell the collaboration guys that, sorry, it's not us dropping the packets. We don't add any latency, we don't drop any packets in our firewall because this traffic bypasses the firewall. So it's not really our fault. In this case, we do it for more bandwidth-hungry traffic, right? Customer E, the final customer. But you're getting the drift. Improve security, avoid having LAN backup go through the firewall again. What the heck, that was the previous customer, wasn't it? The requirement was no redesign of the current topology. Enforcement between verbs should be done in the firewall, single instance of the firewall. In this case, the firewall admin was extremely skeptical of PBR. We had a bunch of meetings before and discussed PBR, and that person was very, very resistant to changing anything. All other traffic to and from the backup server in a specific verb should hit the firewall. We leverage PBR again, this time with the device behind the layer 3 out, finally. More specific contract, like TCP 12345, LAN backup traffic, bypassed the firewall. So initial topology looked like this. Firewall connecting a lot of verbs, like 20 odd something. That was getting old, because at least they were consistent. So whenever they got a new system, they evaluated should they create a new verb. But on the other hand, new interface, new link network, and everything, which made it take a lot of time. It made things more complicated. Because that person spent like a considerable amount of time trying to figure out the routing in their data center between the verbs and everything, and the link networks and all those things. Trace route through the data center for like 2 days. Final topology, just like the firewall admin wanted, exactly the same. Or I'm just lazy when I came to creating powerful slides. But at the end of the day, it was the same topology, of course, because that was one of the requirements. In the specific verb where we wanted to have higher security and we placed the LAN backup servers, we had contract 1, matching IP, PBR to the firewall, once again. But the firewall is behind our layer 3 out in this case. All the east-west traffic hits VCN, contract C1, and is sent to the firewall. North-south traffic, we have another second contract. We have a VCN contract called C2. It matches IP. Everyone is consumer of that one, except for a layer 3 out that is also provider of the contract. I forgot to put a C there as well, because of course it's going to be a consumer of it as well. This is because there is a rule. For one, it doesn't make sense, because the firewall is our next hop after our layer 3 out, which makes it it wouldn't make any sense to PBR the traffic to the firewall, then route out again and hit the firewall again. And probably the firewall would have some objections about that and get confused. But there is a rule in ACI that you can't use the same layer 3 out and do PBR. If you're exiting through layer 3 out and have your device behind it, then you're not allowed to do PBR. And finally, the LAN backup traffic. So everyone consumes the contract C3, except for B as a backup. That one provides the contract, which means TCP 12345 or whatever they were using would hit that contract, be enforced in the fabric, and never see the firewall, because it was overrun by the LAN backup traffic. It was like, I predicted that beforehand, and I said, okay, let's prepare, we can do PBR. And they were like, nah, we don't need to. And like the day after they implemented it, they were like, okay, how can we fix this? So that's how we avoided having the LAN backup traffic hit the firewall. Conclusion, It's possible to reuse current design with firewall between verbs when doing PBR using a device behind layer 3 out. Makes migration easy by doing it step by step, and gives the firewall admin warm, fuzzy feels a little bit about still being in control, sort of. It sort of feels like the traditional way of building things, but we can give them more control within the verb, for example. Remember to avoid doing PBR of traffic going out via the same layer 3 out where the PBR device resides, because that won't work. And you have to change, if you have 000/0 in that case as a route, not route, this should be the external EPG. You have to change it to 000/1 and 128.000/1. Where on the external EPG where the PBR device resides, just for classification reasons. Do we have a mic? Sorry. Yeah. Yeah. Yes, in this case, we're using one tenant. And to repeat the question from... Yeah, you could do this depending on the way the topology looks. Because if we would rewind the tape back to customer B, for example, if they hadn't been using multi-site, we would have been able to do this type of design. Yep. Okay, if the backup server had been in one tenant and some of the consumers or devices had been in another tenant, then we would have to start thinking about what we're doing, because then we would have to leak. To be able to use contracts within ACI, we would have to leak traffic, right, between the tenants. And then we would have to start thinking about which subnet are the backup servers residing in. If we have other servers, or we have things that we would like to have sent up via a firewall, for example, then we would start having a problem. Because then we would have a leak between verb A to verb B, for example. And verb B, if we leak the traffic, we have the route directly in verb B, which means that we have to use PBR or use the contract. So then we would potentially have a problem if it had been several tenants. Yes, sir, correct. Conclusion. PBR makes service insertion very easy and flexible. You can apply different services to different types of traffic, for example, as we've seen. You can apply services between endpoints in the same subnet as well, which makes it very, very useful if you want to do microsegmentation, for example, whatever your definition of microsegmentation is, that is. And it makes it easy to create exceptions where needed, like for LAN backup traffic or where latency is really, really key to keep the latency down, for example. You can use routing to take care of NAT and get around the limitation sometimes that you can't use the PBR device behind the layer 3 out when doing multi-site. Using a PBR device behind layer 3 out can make migration much, much easier, as we saw in the last case, and help win over the firewall admin in case they are a bit skeptical about the magic that they consider PBR being. So my call out to basically explore how PBR can help you simplify your environment and secure it better. I hope it has been useful to you. I hope it's been inspiring. I hope you have learned something, so you haven't been sitting here dreaming about all the beer and finger food you're missing out on. Yeah? Any more questions? Final things, evaluations. You know this. If you liked the session, please show that in your evaluation. If you didn't like it, I'm sure you're going to show it in the evaluation, but please, please, please give me feedback so I know what to change, what to improve. And if you liked it, tell me what you liked, tell me what you would like to see more of, and so on and so forth. Because I would really like to be able to come back next year, be invited back. It's a great honor, and it's been a pleasure. But anyway, continue your education, you know that. My email address, you can join the WebEx space. And finally, thank you so much for spending the time. I know I've been between you and the beers. I hope you learned something. I hope it's been a little bit entertaining. Thank you so much. Have a great Cisco Live.